In this last video, we're going to go ahead and do some examples where we're calculating probability for a sampling distribution of sample means. So our first question says the average lifetime of smoke detectors that a company manufactures is 5 years, or 60 months, and the standard deviation is 8 months. Find the probability that a random sample of 30 smoke detectors will have a mean lifetime between 58 and 63 months. So I'm going to go ahead and pick off information from the problem, looking for statistics vocabulary. And I see average, and connected to average I see 60 months. And I'm particularly focused on that 60 months because the other numbers I noticed as I read through the first time were also in months. The next phrase that I see, statistics phrase, is standard deviation. And they tell me that that is 8 months. And then I'm told to find the probability that a random sample of 30 smoke detectors will have a mean lifetime between 58 and 63. So let's go ahead and organize what we're given. So I know that my data value of interest is mean lifetime of a smoke detector. For a sample of size 30. I know that my sample size is 30 or bigger, which tells me that the distribution of sample means, my sampling distribution, is normal. I know that the mean of the population is the mean of the sampling distribution, so 60 months. I know the standard deviation of my sampling distribution is the standard deviation of the population divided by the square root of the sample size. I'm going to go ahead and do that on a calculator really quick. So 8 divided by the square root of 30 is 1.46. 1.46. I'm going to round that to about 1.5. That's going to help me draw my picture, so I can get a quick idea of what my probability question looks like. And my probability question says, what is the probability that a random sample of 30 smoke detectors will have a mean lifespan between 58 and 63? So I'm going to go ahead and draw our normal distribution. I know the middle is the mean of 60, and I know I go 3 standard deviations out in either direction. And in this case, I'm counting by about 1.5. So 61.5, 63, 64.5, 58.5, 57, 55.5. And I'm going to go ahead and mark where those boundary values sit. So 58 is right about here, a little less than 58.5. 63 is right here. I'm interested in this area here. And I can see that I'm a little past 1 standard deviation on this edge, and I'm at 2 standard deviations on this edge. So I expect this is going to be bigger than 68, but smaller than 95, and probably closer to the 95 edge. because I'm almost 2 standard deviations out on either side, but not quite. I know to run this, I'm going to do normal CDF, and normal CDF asks me for a lower bound, an upper bound, it asks me for a mean, and it asks me for a standard deviation. So my lower bound is 58, my upper bound is 63, my mean is 60, and my standard deviation is 8 divided by the square root of 30. And I'm typing it in exactly so that I don't have rounding error. The rounding error is fine in my picture because I'm just trying to get a quick sense of what the distribution looks like. But in my calculator, I want to be as accurate as possible. So let's go ahead and put that in the calculator. Second vars, normal CDF, 58, 63, 60, and then 8 divided by second square, 30. And then I'm going to go down to paste and hit enter and run that. And we get about what we expect from the empirical rule. We get 0.894558, which is going to round to 46. A little bit less than 90%. And we knew that we were bigger than 68, smaller than 95, closer to the 95 because of that little gap there. And that's a much closer to 95 than it is to 68. So that is right about where we expect it to be. So for a random sample of 30 smoke detectors from this company, we expect that almost 90% of them have a mean lifetime between 58 and 63 months. All right, so let's do our second example. Our second example says the average teacher's salary in North Dakota is $49,296. Assume a normal distribution with our standard deviation equal to 6,225. What is the probability that a randomly selected teacher's salary is greater than 45,000? So first thing is I notice reading this problem that it says randomly selected teacher's salary and not random sample of 30 teachers. This is an individual. So this is X equals salary of North Dakota teacher, singular. Yeah, we're told to assume that that's normal. And they give us a mean of 49,296 and a standard deviation of 6,225. And we're asked the probability that X is greater than 45,000. So this isn't too bad. We're going to go ahead and draw our normal curve. Ooh, that was a little messy there. Mean is in the middle, 3 standard deviations out on either side. I'm going to label this guy sideways because our numbers are so big. So I know my mean goes in the center, 49 to 96. Going forward, I'm going to add to that 49 to 96 the standard deviation of 6,225. So 5, 5, 5, 2, 1, 6, 1, 7, 4, 6, and 6, 7, 9, 7, 1. And then other direction, starting at the mean, so 49296, I'm going to subtract the standard deviation 4225, or 6225. So 43071 36846 and 30621. We'll go ahead and mark our boundary value. So in this case, our boundary value is 45,000, which is going to be between 43 and 49,000. And it's a greater than statement, so we're looking to the right. So my boundary value here is 45,000. My boundary value at this right edge is 1E99. So we're going to go ahead and run it on our calculator. Normal CDF, lower bound, upper bound, mean and standard deviation. Ooh, I forgot my mean. Sorry about that. My poor little brain is a little fried today. So 45,000, 1E99, 49,296, and 6,225. Second bar is to pull up normal CDF. And we get 0.75494, so 49. So about 75.5%. Looking at that curve, I know that this marker here is the 50% marker. I know that this marker here is the 68 plus the 16, and 68 plus 16 is going to be in the 80s. So between 68 and 80 something, I should be sitting at about 70 something. 75 makes sense. All right, for our last example for today, it says for a sample of, I don't know where that line came from. For a sample of 75 teachers, what is the probability that the sample mean is greater than 38,000? This is a little different, and now I'm looking at a sample of 75 teachers. That means that my random variable has changed. I'm now looking at the mean salary in North Dakota for 75 teachers. Because that sample size of 75 is bigger than or equal to 30, I know it's going to be normal. I know the mean is going to stay the same. And the standard deviation is going to be divided by the square root of the sample size. And then I'm asked, what is the probability that that sample mean is greater than 38,000? So for my picture, I'm going to do what I did last time. I'm going to calculate that standard deviation to a decimal that's easy to count by, and I'm going to build my curve, or at least try to if I can draw today, which is questionable. That'll do. So mean, 3 standard deviations out in either direction, and then 6,225 divided by the square root of 75. And it's about 719. I'm going to round that up because we're dealing with really big numbers to about 720, just to do math quickly. So my mean is at 49,296. So 49,296. I'm adding 720 to that. So I get 50,016, 5736, and 51,456. And then going the other direction, I'm subtracting. So 48576, 47856, and 47136. And you will notice that the lower boundary on this curve is 47,000, meaning that my 38,000 is way down here somewhere. And I'm interested in greater than, meaning I'm shading all of this all the way up here. So without even running normal CDF, I have a prediction that this probability is probably going to be pretty darn close to 1. We're going to go ahead and run normal CDF with our modified standard deviation to check. So our lower boundary is 38,000. Our upper boundary is positive infinity, 1e99. Our mean stays the same. We're now taking our standard deviation and dividing it by the square root of the sample size because we're looking at a sampling distribution. And we get exactly what I suspected we would from our picture. That's basically all of the data. All of the data for sample means for groups of 75 teachers is greater than or equal to $38,000. All right. If you have questions on what you just watched in those examples, feel free to send me an email or drop by office hours. One quick piece of advice, you'll notice that the difference between these questions is randomly selected individual versus random sample. If it's a random sample, you're doing sampling distributions with a modified standard deviation. If it's an individual, it's the standard deviation is given in the problem. All right, that's it for week 3. I hope you have a good rest of your week, and I will see you in week 4.